Quiz 1.5 notes. So we're going to answer the following questions about this polynomial in standard form. Now before you answer anything of a polynomial in standard form, first thing you want to do is put it in standard form. It's actually not in standard form yet. It looks like standard form. It's not a factor form or intercept form or other kind of forms. But what we put in standard form, how we do that, we take the highest power and go first. And then we work our way down one by one. So the highest power is negative 3x to the fifth. The next power out after that is plus 5x to the third. Then we have a negative 6x and a positive 8. That right there is your standard form. This is kind of almost standard form, but this is perfectly standard form. From here, we're going to answer these questions, which will actually help you graph it or make a sketch or understand a possibility what this sketch would look like. But we're not actually going to sketch it because this is not the easiest form to sketch, but we can get characteristics of the sketch. So the degree. How do you find the degree? Well, the degree deals with this first term. All right, all we care about is the first term, and what we do is in that first term we care about the power right there, and the power is a 5. So this is a fifth degree polynomial. And then later that fifth degree is going to be important because that is an odd, and that odd will also be important. Next, the lead coefficient of f of x. So what is a lead coefficient? Well, it's the same thing as before, except now we're looking at the number in the front of the highest power. So my lead coefficient is negative 3, and we tend to call that a. A equals negative 3, but you don't have to, but we call it a lot of times. So negative 3 is my lead coefficient. So to find about the in behavior, we're going to look at odd or even, does one characteristic, and the sign of the a value, which is the other characteristic. So there's two characteristics of the in behavior of this graph. We don't care about the number, that's just how steep like the hills and valleys are, and those we can't get exact. So we care about the negative, positive, and odd or even. So let's make a little chart to help us kind of better understand when to do what for these kind of problems. So if your a value can either be positive or negative, all right, and your degree could either be odd or even. This will just help you kind of think it through. So the first thing we do is look at the a value. If the a value is positive, let's look at that. A value positive means it's going to go up on the right, means it's growing on the right side of the graph. If your a value is negative, it's going to be dropping on the right side of the graph. So that's the first thing we want to look at, is if the a value is positive or negative. Now odd or even tells us the left side of the graph. So if it's odd degree, what that means is it's going to go the opposite of the right side. So since it's going up on the right, it's going to go down on the left. Since it's going down on the right, it's going to go up on the left. So as you can see here, odd, they're going opposite directions. What even means is they're going to go the same direction. So for an even, since it's going up on the right, it's going to go up on the left. Since it's going down on the right, it's going to go down on the left. So this is a little legend to know in behavior dealing with the odd or even and the sign. So this will help us understand this one. So if we look at this one, we notice that it's odd and it's negative. So when it's negative, we know it's down on the right, and if it's odd, it's going to go opposite. So it looks like this graph. So our answer here is going to go down on the right and up on the left, which you can describe it in words. There's a lot of different things you can do to describe it. One thing they like to do in a lot of things is say as x approaches infinity, what's happening? Y is approaching negative infinity, one way of saying this. As x approaches negative infinity, y approaches positive infinity. Now, they might be like, what that's saying? What it's saying is x approaches infinity, so as you're going to the right, the y value is going to negative infinity, meaning it's going down, like this picture right here. And as x goes to negative infinity, that means to the left, as you're going this way, the y value is going up to infinity, so it's going up. So this is also notation, pictures, words, all sorts of things, but this is good for now. Lastly, the y-intercept. That will also help you sketch it, because the y-intercept in standard form is really easy to get. To get a y-intercept, what you're doing technically, if you think about it, is you're plugging in 0. It's 0, comma, something. So how do you find that something? Well, what we do is we put 0 into this function. When you put 0, won't this become 0? Won't this become 0? Won't this become 0? So doesn't it just leave us this number without an x? So every time when we put 0 into the function, we only just look at the last piece. So it's 0, 8 is my y-intercept. So it's a really easy coordinate to get, and that will help you sketch it. So with all this, if you sketched your y-intercept, if you sketched the end behavior, you can see the basic look of this graph. If you're kind of just a fuzzy, what about does it look like?